I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life bonus episode.
The podcast helps you understand the chemistry of your everyday life, but twice this week.
Yay, I'm so excited for our bonus episode. So we're starting these for any listener questions we receive because we got some feedback that was preferable to getting rid of content in favor.
Yes, and doing those polls in the past has helped us find the best way to make the most people, the most listeners happy without making any like crazy drastic changes. We're not going to not still answer your questions or anything, but we're going to adjust to a bonus, which I think will be fun.
Yeah, when is a bonus not fun?
Yeah. Before we get started with the questions, we do want to give a shout out to Dr. Charles P. for buying us a coffee, actually 2 coffees, on our little coffee Ko-Fi website thing. So thank you so much, Charles. Yeah,
that's so encouraging. We're actually going to take those coffees and put them towards our hosting fees.
Yeah, absolutely.
Very exciting. And I really don't know if it's Ko-Fi or coffee.
I don't know either. And because they say buy us a coffee, it seems like maybe
it's coffee.
It's coffee, but then they have the hyphen, which sounds like it's Ko-Fi.
And then they don't know then we want people to know how to spell it.
Yeah.
So I'm going to keep calling it Ko-Fi.
Either way, if you give us a coffee, we'll give you a shout out on our podcast. Yeah. So thanks, Charles, and any future coffee givers for helping us keep this show going.
Yeah, that was so exciting.
So our first questions are actually not questions. We've got a few statements this time, or corrections even. So Nikki in had 3 things. The first is, it may be worth mentioning that there are some drawbacks besides the storing of power to solar. That it's actually pretty difficult to dispose of solar panels once they need to be replaced because there are heavy metals and electronics that are hard to get rid of in an eco-friendly way.
Yeah, that is a drawback. And we kind of talked about that when I said we want to build better solar cells, that we're moving away from heavy metal solar cells. My thinking was mostly, it's hard to make solar panels with non-renewable resources like heavy metals. They're also toxic, bad for the environment, not eco-friendly. So while they're harvesting and creating renewable energy from the sun, the panels themselves are not optimal right now. So we're working on that. And that's part of why we're moving towards more organic solar cells.
Interesting. The second thing she said was actually crazy interesting. Solar farms tend to kill birds that fly over them. Like what?
I know. So I knew that was true about windmills. I knew for a fact that was true for windmills. But I read on the Audubon website, Audubon's a big nature bird. They have a whole Audubon trail in the south of the United States. I read about that when she sent that because I had no idea. And it's actually one type of solar which is really bad for that. It's called thermal solar. They take the sun's energy and redirect it and concentrate it to turn water into steam. Basically use it as a heat source, and that steam turns a turbine that generates energy.
Got it.
But even big farms of solar panels can trick birds into thinking it's a body of water, and then they get disoriented and lost and can die there too.
Yeah.
Ooh, so that's some drawbacks. But if you go to the website, audubon.org, why are solar panels good for birds? If you just Google that, and we'll link to it in our show notes, there's information on how to make them more environmentally friendly.
Nice. The Audubon Trail, is that like a hiking trail where you can go as fast as you want?
Oh, no. Oh, no.
Her third statement is regarding the storage of energy, that Tesla made the power wall in an attempt to like fix that problem of storing solar energy.
Right. And that is good for home use, and I think it's moving in the right direction, but we still are having problems with larger scale storage of energy. Yeah, we might do a whole episode about this. Actually, I talked to my colleague, Dr. Who, and for example, one of the main options for batteries would involve hydrogen, which is very flammable and dangerous, and there's just all kinds of problems with them. So I think we could do a whole episode on it, but I think what my big takeaway is right now solar cells are optimal for the individual user. So putting a solar panel on your house won't disrupt nature's environment, won't hurt nature at all. Putting a solar panel power wall on your home is going to solve the energy storage problem. There's lots of options for home use, but we have not come up with enough fixes to replace fuel grids in the same way that we have them currently with solar.
Got it. So those are Nikki's statements, questions, whatever.
I was so excited when I got Nikki's feedback about the solar panel episode. I learned a lot. So those were really fun and good questions. Good job. Or comments, I guess. Good job, Nikki.
We have a few statements from a guy who emailed us named Tom in. He sent an email about episode 14 about artificial sweeteners. And it was pretty long, I understand. So do you want to talk about how that discussion went and what information he had to share with us?
So for my email with Tom, actually, it was a pretty long email. We had a nice chat about it. It was pretty fun to learn about him and his life. I'm going to pull out the main point that I wanted to clarify, and that came from our emailing conversation. And that is, I talked about how in the artificial sweeteners episode, there's the handedness. And the handedness causes it to where if you have the mirror image of a natural sugar, that one won't be digested. But that is not the only kind of artificial sweetener. So you had a really good understanding of that mirror image concept and how our bodies can't digest it. But also sometimes they'll do other things to make them non-recognizable by enzymes. Sometimes they'll invert the stereochemistry or flip that to the mirror image on just one part of the molecule. So, for example, one artificial sweetener is created by taking an alcohol group and getting rid of that and replacing it with a chlorine that's facing the opposite direction. So it's inverting one part to make it. So there's complex, a lot of layers. We could not have covered all of that.
Yeah.
But I just don't want you to leave that episode thinking all artificial sweeteners are made this exact way.
Got it. Okay, cool. So basically, we took a dive into one specific kind, one specific way.
Yes.
Okay, cool.
And I didn't clarify that very well. And there's a lot of problems with production, and which ones are the easiest to produce aren't necessarily those mirror images, but that's a good main takeaway.
Yeah.
For that. So I just wanted to clarify and make sure we weren't spreading misinformation. We are committed to accuracy.
Yeah.
We want to make sure that we're giving you good information. And I work really hard to double check my sources and everything. He also talked about how sometimes we can perceive sweeteners to be much sweeter than sugar. And that is true. And I sort of meant to touch on that, but I don't know how. I think we just kind of ran out of time. But you can perceive some sweeteners to be up to thousands of times sweeter than regular sugar.
Interesting.
Isn't that cool? And I don't know anything about how our brain perceives sugar one way or the other, sweetness. That's a little into biology and brain chemistry and things that I don't understand. But I did know this because this is interesting to me. In my polymer chemistry class, we learned that the regular soda sugar, when they do the throwback cane sugar soda, requires more sugar to make it taste as sweet than if you were using high fructose corn syrup. Because we perceive high fructose corn syrup to be sweeter than regular sugar.
Dang, that's crazy.
So it's actually not necessarily healthier.
Yeah.
Unless you have a hard time with corn.
Right. That's weird.
Yeah.
Not to mention that I don't really even know what high fructose corn syrup is.
Yeah. That's interesting.
Yeah. My wife loves corn though, so I think she's into it, but
yeah, definitely. She loves corn.
Loves that corn flavor in her sodas.
She's a corn husker, so that makes sense.
Actually, that's Nebraska.
She's a Hoosier.
Yeah.
That doesn't help. Okay.
A corn Hoosier.
She's a corn Hoosier.
So that's all Tom's stuff. Thank you so much, Tom, for reaching out and asking those questions and sending us those, kind of clarifying what areas we hadn't made very clear in that episode.
Yeah, that was really helpful. And I really enjoyed our chat.
So now we're getting into some questions from Instagram.
Nice.
Questions people submitted. We did a story yesterday just asking for questions. We'll do that probably every time we do a bonus. So be looking out for that. You can send us a question anytime, but it's kind of fun to do it on Instagram. Leanne R. asked, is glass a liquid? Whoa.
Yeah. So Leanne, that is a good question. And I think we're just going to have to do a whole episode on it. But know that Frosties have been accused of being not a liquid or a solid by Wendy's. And that crazy corn cornstarch thing where you hit it and it's hard and you walk on it.
Yeah.
You hit it and it's hard and then you gently touch it and it's soft.
Yeah.
All those are in my mind and on our list. So good one on you, Leanne.
Interesting. I know what that's called, but the cornstarch in water is called non-Newtonian fluid.
We'll get into it.
Oh, I love those.
Alert.
That sounds so fun.
Yeah,
That's
I think that would be a fun episode.
Great question. Dang. Stephen H., one of our favorite questioners, one of our most inquisitive listeners,
We love it.
asked, from episode 21, can you explain more about your process of making molecules? Is it always a form of growing crystals?
No, that's a great question. So making new molecules is basically chemical reactions. So when I or Doctor Who or whoever goes into the lab, we start with some very common starting materials and we mix them together in right conditions to make a different molecule. And usually we do that in several steps in sequence to finally end up with something that we're aiming to get. After each step, we stop and we purify. So you can imagine me coming into a lab and mixing some solids and some liquids and putting it on a hot plate and letting it run for several hours or even overnight, and then coming back and stopping the reaction and purifying, making sure everything is just the one molecule that we want. When you mix things together, you really don't just get one molecule. You usually get lots of side products. Mm-hmm. So we purify and then react it forward to the next one. Mix that solid with some new solid, put it in some liquid. That's kind of what we do. And eventually the end goal is usually to make something brand new that's never been made before. Mm-hmm. And I did get to do that, which was really fun when I was working on my master's. And has made, Doctor Who, she's made many molecules that no one else had ever made before, which is really cool.
That's crazy.
Yeah. It's pretty incredible. Kind of thinking of getting my one molecule tattooed. I think that'd be fun.
That would be cool. You know what the phrase growing crystals, I always think of when they use those crystals for that like weird seen on TV time machine in Napoleon Dynamite.
I have no idea. No idea.
They have these
what
crystals.
Are you talking
about? They have these crystals and it's supposedly the thing that like makes this little time machine work. It's like such a stupid little like order, to the mail. Mm-hmm. And it's like, oh, I forgot to put the crystals in. And then it's like these little crystals that they just put in this thing as if it's going to just make it all work. I imagine that's what your job is like.
Yeah, absolutely. That's what my job is like.
Yeah.
Well, I will say on the topic of growing crystals, we are going to talk more about what growing crystals means in just a few episodes. We already have it planned out, but growing crystals is something you do with a very pure substance, and then that crystal can be investigated for structural properties. It was very challenging to do usually. So
that sounds crazy.
It was really fun. I really enjoyed my time in the lab. It was great making new molecules and knowing that you can manipulate atoms to turn them into something else to sort of bend to your will. It was crazy cool. The ability that scientists have to have figured out that we can do that is mind blowing to me. I'm just amazed by science.
Yeah.
Which I guess is why we're all here.
Yeah. Actually kind of feeds into the next question, which is from Christine Y. She asked, what do you do as a chemist now?
Yeah. So now I actually decided to leave the lab because I really, really enjoyed it, but I found that I had a greater passion for communicating about science and science education. And currently I'm helping to teach classes on organic chemistry, general chemistry. Sometimes I work in labs to teaching labs. And my research is on how people learn organic chemistry. So what misconceptions do we have about it? What things do we perceive it to be attitudes students have walking in the classroom? How can we make them more excited about it? I don't think it's a secret that people hate organic chemistry, and I don't know why.
Yeah.
So we're going to do some work on that, and it's been really fun. and I've gotten to learn a lot. And then I get to do this podcast, and all of that sort of falls under the purview of chemistry education and communication that I'm looking to do now. Mm-hmm. That's it. That's pretty much what I do as a chemist.
That's a good question, though.
That is a good question, yeah.
Especially recently talking about what you were doing in your master's. So the next question is very not about chemistry. It's from an account. We couldn't figure out the name of this person, but the question is, what is your favorite city in the world?
I love these questions that are not about chemistry. I think it's fun. And I've actually gotten a lot of feedback from our listeners that they want to learn more about us.
Which is surprising, so we're not going to give it to you. Sorry.
No, I love these. So anyone who wants to ask just weird questions about me and Jam, go for it.
Yeah, anytime.
Wow, I really had to think about this one. I really loved being in Copenhagen. It was beautiful. The food was amazing. I went there with my mom, so I have a great memory of that.
Yeah.
But in the States, I think I would go with Washington, D.C.
Interesting.
I really loved it there. I felt like I belonged there.
Yeah.
But honestly, really, isn't my favorite city the one where I live and all the people I love are? So I don't have an answer. I just went with top 3. It's too hard to narrow it down.
That's sneaky. Well, since you did a top 3, I'm going to do a top 3 also.
Nice.
Kind of thing. So
we just took this question and made it our own.
Yeah, we totally did. But I think it still kind of answers it. It's not, I mean, it's hard for anyone to pick their favorite city. I bet even the asker would have a hard time.
Yeah.
So one I'll mention is I when I was in high school, I went on a Europe trip, and one of my favorite cities that we went to of that whole trip was Florence, Italy. It felt like man, I could live here.
Yeah.
I didn't make any dreams or plans about it, but I felt very much at home there.
Yeah.
Great food. It didn't feel like there's not one super touristy thing to see there.
Yeah.
It's just a famous place. It's been there for such a long time. A lot of famous people have lived there, but it's been more like an art hub. It's not like it has a Coliseum or a this or that. And I really liked it. You can walk almost everywhere. So that's one. The Tiberias area in the Holy Land, around the Sea of Galilee, is whoa, that's a really, really pretty area. And then really recently, the town of Wanaka in New Zealand, in the South Island. So those are dear cities to me that I loved time there. So it's hard to pick between those 3. And there's probably others I'm not thinking of right now that would be equally dear, but those are just a couple of attempts at an answer.
Yeah, I'm thinking of all the places I've been, all the places I traveled in Europe and the United States. It's hard to think of one.
Yeah, it's easy if you just eliminate the United States.
Yeah, I'll just do that. I'll just eliminate the United States.
Okay, the last question we have is from J.E., and the question is this: where is chemistry?
Friend of the show, J.E. The answer is everywhere. Chemistry is everywhere. And on that note...
And that might seem magical, but if you think about it more, it's actually terrifying.
Oh, God.
It's all around us. It's out to get us. Save yourself.
You're not allowed to call chemistry terrifying on this show. I'm editing. I'm vetoing that.
It's too funny. It's going to stay.
It's not. All right.
Well, thank you guys so much for your questions. If you have any future questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. And we'll probably reach out and ask for them when it comes time to do our next bonus episode. If you enjoyed this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts. That helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and J.M. Robinson. J.M. Robinson is our producer, and we'd like to give a special thanks to E. Robinson, who reviewed this episode.